Okay, so welcome back and to the third part of the SARC Day. I am going to present a few PIAS tips and tricks. And those are divided in two parts. Most of the tips and tricks will be just useful tips in the daily use of PIAS, and there will be a few more specific tips for advanced or dedicated applications. I would like to start with layout scripts. There are two parts of scripts, both regarding the output, computation scripts and output scripts. And computation scripts are for settings regarding the calculation of tank data. I will show you in a moment. And output scripts are regarding the data that will be shown, so the particulars which you would like to see in your tank tables, but that I will not show. For example, not sure. Yeah. For example, you can use several computational scripts. For example, for wing tanks and double bottom tanks, where double bottom tanks normally are lower, and so you would maybe like to use a smaller computation step. I hope it's good readable, because earlier I also saw, when I was sitting in the audience, that on the beamer not all data is equally good seeable. And what you are also seeing here in the end of what I was doing at the end with calculate, you can see that, where is it? Oh, here. In the column for calculated, most are yes but obsolete, so there are changes that not have been yet calculated. And for the wing tank and the double bottom tank that I used for this example, I selected both tanks, and for these I used the two scripts I just created and executed the calculation. And here you see that one can be shown by PIAS that you have now the correct or desired data in the step you desired as displayed in your script. Gaat het nou niet meer? Oh yeah. So if you then print them, one can see two scripts. The standard computational script is created for the wing tanks, and here the user-defined computation script for the double bottom tanks, where the calculation steps are significantly smaller. And then the next tip in layout regarding watertight layout. So the watertight layout contains all compartments that can be flooded in or are valid for damage stability calculations. That might sound a bit silly, but there can be compartments that are not included into the watertight layout. That can be, for example, for vessels also carrying grain, where the grain hold is created as a netto hold, so without the ventilation ducts and such. And this is then an overlapping compartment, which you do not like to have included into the damage stability calculations two times. That is done within the normal compartment list. One can use the drag bar. And then most far right, the column part of watertight layout is shown, and there simply one can switch on or off a compartment to in or exclude the compartment into the watertight layout. This can also be done for or in or excluding compartments into the loading condition. For example, an engine room does not need to be included into a loading condition, and can therefore be excluded in, for example, this this column. These columns now can be, of course, very handy to be seen when directly opening a layout. And these columns can be shifted, and they can be shifted as followed. One can drag in the screen onto the into the column which one desires. One clicks, keeps pressing the left mouse button, and simply drag the column to the desired position. And now the both exampled columns can be seen directly when opening layout. Wat is hier nou zo interessant? Oh, dat is nog een keer de video. Zo, oké, sorry. And now, well, useful tips in the use for daily use for PIAS. For example, also one can select several cells, and that can be done in 3 different ways. It's by dragging the mouse, as I did just by switching the columns, but also several cells can be selected that way. Shift and clicking mouse, and a more dedicated or selection can be made by keeping pressed Control and mouse, and that looks as followed. I choose to make this example by changing the FSM type of these lub oil, lubricating oil tanks in loading. So by dragging mouse, it's simply selecting one cell, keeping pressed the left mouse button, press the space bar, and then the FSM type can be changed. The second is then by clicking, no, it's hetzelfde. Kan dat nou? Oh yeah, sorry. By selecting the uppermost cell, pressing space, shift. Is het nou toch gewoon weer dezelfde of niet? Oh no, this is sorry. Now I made a mistake. This was already with Control. Right. Connection between layout and loading. So up until last year, we had the function where things needed to be reread by using a button. That is now not necessary anymore. The reading from tanks is now directly done when entering layout. And the advantage of this is that changes affecting volume and center of gravity are directly read in. And now also settings can be made independently per loading condition. So this is what it looks like. For example, one can choose one of the earlier shown selection methods. For example, I now used the weight groups. One can just select one of the cells or several, press the space bar, and then selection can be made to which weight group the tanks or the tanks should fit. And the same can be done by for the density. And because the beamer is not that clear, here is also a small, or better said, a little bit larger example of how these windows look like. Another tip is damage cases. So damage cases can be made, in loading, but damage cases can be used for several damage stability calculations. They can be used for deterministic calculations in loading. They can be used for hydrostatic calculations in hydro tables, and they can also be used in PropDam or maybe also in 3. And the selection can be made here. And a little bit zoomed in, it looks like this. And in this selection columns, the user can select or deselect the calculations to which the damage cases should be used. Another tip is the different types of output or PIAS generates the calculations, and these 4 are looking very nicely: a rich text, tab text, and image. But what does it mean? Well, for example, we start with the first, rich text. One can select the kind of output here on copy page. And rich text is to be used, or is the kind of text that is used in Word or an equivalent text program. Text is just plain text, which one would use in Notepad. Tab text is to include the output in Excel, like shown on the right. And an image makes an image. I personally do not use this option at all, but I figured maybe somebody would find it easy to use it. Then the wind moments. Wind moments can, well, be built up from several wind contours. That has to do with the resistance coefficients that can be different for different contours. For example, box framed constructions have a different resistance coefficient than the contour of the vessel has. And wind pressure, I would like to show you how the wind pressure can be defined and differ per zone. But first I would like to show then the wind contour with subcontours. And oh yeah, there's a video. So this is how it looks like. I just created a group ship and cranes. That's the contour, but it's built from 3 subcontour ship and the 2 deck cranes of the vessel, which differ in resistance coefficient that I just made up, so it's not the correct resistance coefficient. And these are wind pressures per zone. So I just remained the IS code like it normally used for this vessel, where we just see a zone that starts at the waterline of the vessel up until the eternity with 1 equal wind pressure. And I made a set with several wind zones. This is what it looks like indeed. So up until 1,000 meters with 1 wind zone, wind pressure, excuse me. And now we see here 3 different wind zones. Each 10 meters high, where the wind pressure decreases by 20% of the normal wind pressure. But also this is just an example to show how it works. And then we come to a more dedicated problem, and that is, or problem, a tip, and that is code meter, the license access permissions. So if you are working with more than, or with several PIAS licenses, but for some modules there are less licenses than PIAS licenses are available, it can, for example, for grain, then the user that starts PIAS first also has grain, but that is maybe not wanted. So, and then one can choose rights for the users that should use this told license. And I also made a video of showing how that can be set. So we start with the nice scenery of the port of Krefeld. And then here one can open CM code meter control center and go to the web admin. And here directly all the available PIAS or module licenses are shown, with also the number of available licenses. Then one chooses the server configuration and choose the permission, the license access permission. It's an advanced setting where one can choose the firm code that should be confirmed, and then the dedicated product code, or now the code of the module that one would like to be accessed by just a few chosen users can be selected. And here I just now select a user and add that user to the list. And by applying this, this selection is now confirmed. And now only I can use this, together with the local host, can use the license of the module. So in short, these were a few tips and tricks in PIAS, and I would like to ask whether you maybe have another tip or trick that I did not add into this presentation, or you have questions regarding the few tips I just presented to you.
I have a question on that last part. Why should you assign a dedicated license to a dedicated user? Why should you do that?
Well, from what I understood, it is why you are doing it is if you have, for example, 5 licenses of loading, but only 2 licenses for grain, you would like, maybe when 2 people are working with grain, you would like to say that 2 people need the grain license, and otherwise, you know, when I would start loading earlier than you do, I have grain and you do not have grain. And that is then, when you would like to work with grain and I'm not working with grain, that would be inconvenient, and that's the reason why that's for.
Another example, what we do, we have one AutoCAD license,
yeah.
And I have assigned it to the...
So one moment, Jan, I'm coming to you.
To share this, the use of this, to share the use of this function. What I did at our office, we have one server on which we calculate probabilistic damage stability, and I have assigned our only octo trading license to only that computer. So people are forced to use that computer and no one else. Otherwise, if one would start prop down, he would take that license on his own computer.
Yes, yeah, indeed. Yeah.
So it can be very useful.
Yeah. Okay, thank you. Yeah. Oh ja. Even kijken hoor, ik kom eraan. Ja. Okay. Oh, you left it right.
Thanks. Now that you mentioned grain and maybe not having the grain license, that's what we do not have.
Right.
But sometimes we check files which do contain grain conditions. I can check everything else, so it doesn't matter. Only I get error messages. With every click I do, I have to 5 or 10 times say, okay, go away, error message. Is that something that can be solved?
Oh, can it be solved? Yeah. Yeah, it can be solved. Yeah. We will be in touch regarding that. René, jij had ook een vraag, hè? Ja, oké. Oeh, dichtbij.
When I change the colors,
yes.
Is that per ship or on every ship on my computer?
No, that's for you as user. So you would. I'm not sure whether, yeah, we're too near, I suppose. No, yes, but that's for you as a user. So it's not per ship or per project, but it's for you as on your PIAS, in your version, you change the settings and you can also change them back if you. Okay. Yeah, I suppose that has to do with mobile phones. Yeah, no, okay. Thank you. Are there any more questions? Yeah, okay, yeah.
Yes, about the data exchange between layout and loading. Is it possible to use multiple modules at a time? I always use one module at a time.
So the problem is when you use several modules at a time, you will overwrite data that you just changed in another
okay, so that's
module.
Still how it works. Yeah.
That's still how it works. Yes. Yeah.
Okay.
Okay. Thank you. Yeah. Oh, yeah. Sorry, sir.
Does anyone have problems with waiting a long time between changing between loading conditions, exiting one and entering another? It takes like 30 seconds. Okay. Or is it just maybe with us? Or from GUI, entering the GUI and loading condition, and then exiting it, and everything freezes for 30 seconds or something like that?
Only when, so you are in loading and you're changing from one loading?
Yeah, you enter one loading condition, you want to exit to enter another one, and it takes every time around 20, 30 to 30 seconds.
So, oh, right, yeah. That can be the server search list if your module. Oh, sorry, the license. That can be solved, yes. Yeah, This is quite a dedicated difficulty you are now facing, but we will have a look via video call, and then or team view, and we can fix it. Yeah. Hello, sir.
Would you consider the possibility, at least I noticed that I can't include a tank defined in layout into the empty ship weight for the loading condition. Let's say it's a tank that I want to keep permanently filled and be accepted to be part of the empty ship. Would you consider implement this, or if there are reasons why that's not possible?
Yes, it is possible, and you can do that by when you choose in the column in loading condition to yes for this tank, the tank will also be included into loading conditions. Or is that not what you mean?
I would like it to be part of the empty ship category, so to speak.
You can copy the weight and the center of gravity for the weight item into the light ship, because if it's a tank, you could empty it and load it, which is not allowed for the weight ship because I changed that. So the tank can be changed and the light ship weight cannot. So these two cannot mix, but you can copy the weight inside that thing into your light ship.
Yes, it would be a little bit flexible to have the possibility to, let's say, defining layout as something that is a tank that I foresee to be permanently filled as I like to be part of the entity.
Yeah, well,
I know it's, I understand it can be done.
And possibly you could have an argument with classification societies if you do, so it will, I don't think it will come soon. Okay.
Sorry. Okay, thank you, Bart. Yeah, no, I'm not sure. Any more questions?
Thank you, Justin, and thank you for the questions. If you have some other questions, we can discuss them during drinks. But first of all, we have to do my presentation and then Herbert's presentation. Herbert told something about a subdivision plan and an AutoCAD plugin. I will show you a movie. Kunt u die dan starten? Zo? So this student made a plugin for AutoCAD. This is the plugin. Here you can enter the length, the breadth, depth, all the information about the ship. Now he's entering the deck height. He's adding a propeller, an engine, all that kind of information which isn't included in PIAS, but what you need for the drawing. And now it's rendered on the right. Yeah, I mean it's what the student made within 3 weeks by himself with the XML output. We can share this plugin with you if you are interested, and we are happy to invite you to improve it even further. That's about the this part. Then we have the layout battle. Layout, you are probably familiar with this. We have 2 ways of entering compartments within PIAS. We have the integrated use of bulkheads and decks method. It's fast, flexible, and money-saving. But there are still some clients without this feature, so using the coordinates. The coordinates is just by entering the length and the breadth of your tank. And you have to define this for every tank itself. Bulkheads and decks, I always compare it with a kind of a pie. You slice it into a few pieces, you put some pieces together, and you say, okay, well, this is the main compartment. So we want to demonstrate this with 2 of my colleagues who are going to working on the exact same vessel. On the right will be Abraham. He will do it following the coordinates method. And on the left, well, he will sit here in the middle, is Victor, and he will do it by bulkheads and decks. It is the exercise of the online training, so perhaps it looks familiar, at least I hope. Yeah, well, come here, Victor, and let's start the timer and see who's faster.
Ready? Yes? Okay, start.
Victor finished. And Abraham, how far are you? Yeah, thank you both. This was to demonstrate the advantage of the buckets and decks method. Yeah, thank you for seeing this. Thank you, Victor. Okay, now it's... Hey! Yes, it works. So now we will have the last presentation. Herbert Koolman will give the presentation, which has a subject, Tell Me. It's a summary of the compit, which still will be next week. So, Herbert, the floor is yours.
Thank you. My last presentation. Indeed, next week will be Compit conference in Germany. That's a larger conference on the application of computers in and of computers and IT in ship design and ship operation. And there I will have this presentation called Tell Me. Actually, Tell Me is a song by Tom Waits. This is Tom Waits. I'm not going to play that song because I think that in the whole audience there will only be one person that's happy with that. That's me. But anyway, Tom Waits is listening to this gramophone. And it is on the acceptance of innovations. And here I look back a little bit and forward. Look back to the childhood of SARC, to the adulthood, looking and concluding, looking back, and then on the future with a question mark behind that. The childhood of SARC, the 80s. For those of you who don't know, SARC was founded at May 1st, 1980. So that makes we just celebrate our 43rd anniversary. And what we essentially did in the early years was replacing manual labor. The 70s, the 80s were the days that you had to make all kinds of tedious stability calculations by hand, and all kinds of tools that were invented for that, planimeters, slider rules, those kinds of things. It was really tedious and very time consuming. And in those days, a complex damage stability calculation might take 1,000 hours, and that was reduced by a factor 10 to some 100 hours in those days. And now it takes an hour or something just for calculating. I mean deterministic damage stability calculation. That made the market reception very good. Everybody wanted to use that software. Who doesn't want to make such savings? And also made the market, let's say, very flexible in the sense that people could imagine that further improvements would follow. I remember having sold my first hull shape generation tool to a company called Schijf Smit in Westerbroek. That was the first user of PIAS. And actually, the module could only produce a ship of 60 meters length and 12 meters wide. And they wanted to buy the software. And I said, well, it's not finished. It's only for 60 but times 12 meters. And the guy said, yeah, I understand. If you can produce this, then you also can change it to other main dimensions. So he had trust into further developments. And why was that the case? Yeah, not that the guy had trust, but why this smooth market reception? Because PIAS did essentially the usual and familiar work. It did the same what people were doing by hand, but then on the computer. So that was the beginning. Yeah, and after that, it was a little bit, it was quite easy, adding ever more and more and more computational tools, such as deadweight scale, probabilistic damage stability, grain hopper stability, well, you know the list. of modules in PIAS, from which most of that was conceptualized in those days. So about, let's say, 15 years later, the PIAS came a little bit in his or her, I don't know, its adulthood, with more functions, more features, more output formats, more options, more support. For example, the integrated manual and the instruction moving we have been discussing today. Somebody, I think Mark might have shown our ticketing system where still 500 tickets are open, and okay, that's quite a fast number, but already 2,500 are closed. Some of them were invalid, but most of them have been dealt with. So that's more of the same. So we may conclude that essentially this development is more or less finished after 40 years. And with that I mean essentially, in the essence. That was on the usual, let's say, common development of software. There are also advanced developments. We have told you today a little bit about that. On software collaboration, on integration and interfacing, on the balance between computational accuracy on the one hand and computation time on the other hand. Enhanced representations or algorithms. As we have shown with the layout battle a few minutes ago, we did not make that for nothing. We made that also not because it's advanced, but because it saves you time. So it's all aimed at improving the effectiveness and efficiency of the program. And we try to explore fruits of novel technologies such as fast optimization, machine learning, and AI. So there are a number of advanced developments. I've shown this list to you earlier today, so I'm not going to repeat that. It's on Fairway and multi-threading and all those kind of things. There are also a number of items that we have not elaborated today, such as container optimization in local PIAS, the Cadmatic PIAS interface, the interface between Cadmatic and PIAS, and the interface with DNV Poseidon. That's a structural scantlings program of DNV Hamburg. This is the interface between PIAS and Cadmatic, and it works really nice because they don't share files, they simply send messages to one another. So there are two windows on the same screen, it's PIAS, Cadmatic. If you change the bulkhead location here, then it's automatically and instantaneously updated in Cadmatic. Very nice, very advanced. This is resulting from the interface from PIAS to DNV Poseidon. This is a picture of DNV Poseidon, and this is the program DNV Poseidon is rather tedious, a rather user-unfriendly program. But if it's fed directly with PIAS input, then you can save a lot of time. This directly comes from PIAS, this also. So that's nice. But the reception of these advanced developments are not particularly warm. The sales ratio compared to conventional PIAS modules is about 10% or something. And I've written this down very nicely and in a commercial, responsible way. I could also say it in another way, nobody buys it. That's true. Why? The question is why? Yeah, well, I can look back to that. I don't know, but in the complete paper, this is a complex story. In the complete paper I will present next week, I announced to ask you today. So the paper has been written, and I announced to ask you. I made the questionnaire, and please fill in this questionnaire. It's lying somewhere there. Where you can provide arguments for not using mentioned advanced software modules. So if you are using it, you don't have to fill that in. If you have additional wishes, you also don't have to fill it in. It is simply the reasons why you do not use that. I made some estimations because I had to write the paper. It could be, but it's my speculation. You can prove that I'm wrong, but we will read that from the forums. It can be that the offer is not convincing from a commercial point of view, Or in other words, the benefit compared to the cost is low. Could be an argument. Could be that the offered functionality is not sufficiently complete. For example, if it's a pilot version. It could be that the proposed functionality is not according to de facto standards. And it could be that the proposed functionality is not according to legal standards. There are some comments to be made on these presumptions. I'm not commenting now on that because it are my own presumptions, and then I'm commenting my own presumptions while I'm asking you, so that would not be very fruitful. But I want to comment around the container loading optimization. We produced that around 2005. That was an optimization feature in local PIAS, where you could basically have containers to be shipped on the quay, and that need to be loaded onto the vessel, with the boundary condition that there is sufficient stability, and with a lot of other requirements, for example, that it is efficient if the vessel will make a trip along different ports, that the container for the next port is on top of the stack and not on the bottom of the stack, because then in the next port you first have to take all containers out and then the container for that port and then put them back in again. So this is a known problem when loading containers. And by that time they did it manually for a certain type of vessel, cost a day. And I came there with the ship owner, very proud. And it was 20 years ago almost. And it took with our program 15 minutes. So that is quite an achievement, from day to 15 minutes. And the guy said that was unacceptable because it should be done within 5 minutes. I said, yeah, okay, but it takes 15 minutes. The point is, they never bought it. We lost our interest. And he still uses a day for that. And if he would have ordered it, then by today, with using all the technologies there are, multi-threading, it would certainly have gone down from 50 minutes to 5 minutes. But never sold. So there are some considerations here. The question we may ask ourselves, is the market happy now? Is there no real need for advanced software? Are you happy with the stuff you have now, with all the features and functions and all the things in there? It could be, because back in the 80s, we witnessed a productivity gain of a factor 10. That was after when all the calculations being done manually. And now the days of a factor 10 are over. Now it's by an estimated factor 1.5 or 2 or 3, something like that. Although the acceleration of the process is not the only consideration, today everybody is expecting salvation from big data, artificial intelligence, and machine learning. I don't know if you are here familiar with the National Maritime Master Plan, but that's on the energy transition, supported by the application of computer software, mainly big data, AI, and machine learning. But the question is, again, do people really want that, or do they only say that they want that? Okay, I draw a number of conclusions. The norms and standards, the existence of norms and standards, can stimulate or prevent innovations. But please realize that sticking too long for an outdated standard leads to stagnation. Then you are simply glued to the old. We will pursue to better quantify cost benefits of our innovations. For example, the layout battle we have just shown you. That's not a paper and an explanation of the inner working. It's simply a demonstration what the benefits are. And please consider that a ship designer is not a software developer. I know that, we know that. Nevertheless, some knowledge of software development background and on the methods in the software and behind the software can be of assistance to user. Fortunately, there is a school in the northern part of the Netherlands, NHS Stenden, which provides a course on this. There are some leaflets on this course laying outside. There will be a webinar tomorrow at 7:30, tomorrow evening at 7:30. But the contact details are on the table outside. please realize that in the case of a software with pilot nature, SARC will emphasize that the included functionality is only a preview. It is pilot, and it is not the final set, and that the software will grow during its usage and its further development. This is what the guy from the container optimization should have realized. On the other hand, please realize that we will only finalize up to the last detail software on basis of a proven interest. And that means more or less a contract. We are not spending weeks and weeks of development if we don't know on forehand that users are going to use that in some sense. And users, that's you, are asked to accept that the days of productivity gains of 100% are over. But on the other hand, I realized when writing these slides, also the risks of buying new software are also much lower. After all, in the 1980s, when I came in my car, my second-hand car, in the shipyard, one bought a software package with the price of an average car, more expensive than my car. So I could directly buy a new car, but that. But the innovative add-on modules today are for the price of an electric bicycle. So why not take that risk? And 40 years ago, they took the risk for the price of a car. Then on the future, of course, you are asked to say whatever you like and to fill in the form. But awaiting that response, we will proceed with the developments of the novel software tools that we have shown you today, because until it is demonstrated or proved otherwise, it's still our belief that this will serve the maritime industry and the maritime community. And on one final slide, I am not complaining. It is not that SARC is moribund. Business is going well. This is a picture of our new office. We invested quite some money in that. Everything for the longer future. So it's not that we are complaining on poor commercial results. It's just that we are wondering which direction to take in the future. Ha, nou zijn ze stil.
So thank you very much, Herbert. Thank all of you. Now it's time for drinks. It's not at the same location as we had lunch. If you go here back up the stairs, you go past the front desk, then go to the left. Don't go upstairs, don't go downstairs, then you end up in the casino. We can go after that, but go to Zaal Brussel, and there we can have drinks. So thank you all for your time today. Thank you all the presenters, and see you over there. Thank you.